Thanks. All right, good. So, hello everyone. Basically, good evening in California, good morning in India, I guess, and good afternoon in other parts of the world, wherever you are. Today's topic is going to be very, very interesting topic, and it's called master algorithm. Before I get into all the details of master algorithm, I would like to you know make an announcement here. The announcement is U.S. time has changed. So basically, tomorrow, not 10, today midnight, the U.S. time will change, and because of that, 1 hour people who are in India, they'll have to. I mean, that nothing will happen to them. For us, in the morning, instead of starting at 7 o'clock, we'll start at 8 o'clock. So West Coast time, people who would attend from California, the morning session will be like a tomorrow morning. It will be 8 o'clock. It is only the morning session, and we have two evening sessions, 6 o'clock in the evening. Basically, today. So from next Saturday, probably we'll start at 6:30 because otherwise it will be too early. Also in the morning for people. So we'll send you all the we'll send you the change in the timing. Nothing. Only thing is West Coast time morning session will start at 8, and Saturday evening session like today is fine because today the time is the old time, but from tomorrow it will change. From next week it will start at 6:30 instead of 6. So for you it is I think it's here in India, it's now I think quarter to 8, I guess. So you start at 7:30, but your morning session will start at 7. So that's about it. So because we cannot start at 7 here, and then it will be a little late dinner time for people, joining West Coast time. So that's the little change we'll have to make because of the change in time. All right. So that's about it. So having said that, we are going to start now, and so just a minute. Uh, let me set the screen first. Mm, I guess everybody can hear. So I always start with a video. This is a very fascinating video. The gentleman, you can see his name is Jeffrey Hinton. He is the godfather of AI. And there were basically three people who really built that AI, not AI, deep learning, which is practically AI now. So Jeffrey Hinton, Lee Kun, and Joshua Bongio from Canada. So they are the three godfather of AI. Because of that, they got Turing Prize. Turing is the equivalent of Nobel Prize in computer science, and so we'll discuss more about that, even the Jeffrey Hinton's theory. Probably not today, because today we are going to talk about the master algorithm, the basic stuff, how the algorithm started, and what's the relationship with mathematics and physics and other branches of science. And the next week, it will be divided into two parts: master algorithms part 1, and the next week will be part 2. We might probably extend next week, half an hour extra, because a whole lot of things to cover. So I mean, 4 hours, 2 hours each is not enough basically to talk everything about algorithm and master algorithm. But I will try my best to give you all the best of the best, knowledge out of it. So just watch this 4-minute video, what he's saying. And if you cannot hear it, Rabi or Sachin, please let me know if there's problem with video streaming. So I'm playing Dr. Jeffrey Hinton. what he's saying about the master algorithm.
So you left your job with Google in part because you say you want to focus solely on your concerns about AI. You've spoken out saying that AI could manipulate or possibly figure out a way to kill humans. How could it kill humans?
Well, eventually, if it gets to be much smarter than us, it'll be very good at manipulation because it will have learned that from us. And very few examples of a more intelligent thing being controlled by a less intelligent thing. And it knows how to program, so it'll figure out ways of getting around restrictions we put on it. It'll figure out ways of manipulating people to do what it wants.
So what do we do? Do we just need to pull the plug on it right now? Do we need to put in far more restrictions and backstops on this? How do we solve this problem?
It's not clear to me that we can solve this problem. I believe we should put a big effort into thinking about ways to solve the problem. I don't have a solution at present. I just want people to be aware that this is a really serious problem and we need to be thinking about it very hard. I don't think we can stop the progress. I didn't sign the petition saying we should stop working on AI because if people in America stop, people in China would. It's very hard to verify whether people are doing it.
There have been some whistleblowers who have been warning about the dangers of AI over the past few years. One of them, Timney Gebru, was forced out of Google for voicing his concerns. Looking back on it, do you wish that you had stood behind these whistleblowers more?
Timney's actually a woman.
Oh, sorry.
So they were rather different concerns from mine. I think it's easier to voice concerns if you leave the company first. And their concerns aren't as existentially serious as the idea of these things getting more intelligent than us and taking over.
Steve Wozniak, one of the co-founders of Apple, is also speaking out about the dangers he fears will come from AI. Take a listen.
Now, AI is another more powerful tool. It's going to be used by those people, for basically really evil purposes. And I hate to see technology being used that way. It shouldn't be. And probably some types of regulation are needed.
It sounds like you agree.
I agree with that. Yes.
Yeah. What should that regulation look like?
I'm not an expert on how to do regulation. I'm just a scientist who suddenly realized that these things are getting smarter than us. I want to sort of blow the whistle and say we should worry seriously about how we stop these things getting control over us. And it's going to be very hard, and I don't have the solutions. I wish I did.
Does there need to be a meeting of all of the tech groups and governments working on this, Google, China, whatever, and some sort of set of rules of the road? I mean, how do we even protect against bad actors or rogue nations harnessing AI?
So for some things, it's very hard, like them using AI for manipulating electorates or for fighting wars with robot soldiers. But for the existential threat of AI taking over, we're all in the same boat. It's bad for all of us. And so we might be able to get China and the US to agree on things like that. It's like nuclear weapons. If there's a nuclear war, we all lose. And it's the same if these things take over. So since we're all in the same boat, we should be able to get agreement between China and the US on things like that.
Do you think that tech companies will be the solution, or are they so invested in this financially, and also, let's be frank, in terms of power, that they're not going to be part of the solution here?
I think the tech companies are the people most likely to be able to see how to keep this stuff under control.
Jeffrey Hinton, thank you so much. Come back. We have more questions for you when we
All right. So everybody heard what he said. He's the godfather of AI. So was it clear? I mean, I got a new mic and everything. So I don't know, the sound was clear to you, or the streaming was okay, or it was slow. Can anybody tell me anything that was it a clear everything?
Yeah, it's
Okay.
clear. Clear.
Okay, cool. So everybody was understood that we played Dr. Jeffrey Hinton. We'll be discussing about Dr. Jeffrey Hinton's deep learning and what he really invented, probably in next class or next session. So So you heard what he said. So AI is basically is going to destroy the humanity. It's more dangerous than nuke. Even the Stephen Wozniak, who is the uh, founder of Apple, basically Steve Jobs was kind of a marketing, a design guy, but the main technical of Apple, all this Macintosh and all, Steve Wozniak, who is still alive, you saw him. He's the main technical person. He's the brain behind Steve Jobs, who really invented Mac and all those PCs and everything. So he said that it's very very dangerous. So where we are heading basically, we are heading to some kind of AI control, world, and if that happens, a lot of things might go wrong, and when that go wrong, it is more dangerous than nukes, all the nukes combined. So whatever the nuclear weapons out there, Russia, China, and all those other countries, India, Pakistan, and whoever has a nuclear weapon, if you combine all of them, and then the kind of a threat it can create, AI creates more than that. AI is more dangerous than nuke. That's for sure. Okay, now having said that, so first we have to understand where we are heading. AI is a tremendous opportunity, and I have every reason to believe it's not going to happen that way, because humans are smart basically. Even there is China and US, and Dr. Hinton also said that with existential threat, so always China and US and other advisory countries, they'll come together on some kind of uh, you know consensus building process to control the AI in a very very ethical way. And then I have my own suggestion, for AI. So even there was some panel discussion, United Nations panel discussion, where I'll share that video with you. I shared my own, ideas about how to tame AI. So that's a different thing. I'm not going to talk about that, but I'll share the video with you. I think it's on our YouTube channel, so you can watch it if you're, if you subscribe to the channel. Now, so master algorithm is one algorithm that controls everything. So how do you get into the master algorithm? What are the things, and what is that algorithm? What is the difference between programming and algorithm? So today is like a more of a little bit of scientific and little bit of deep thoughts into it. It's gonna be little difficult to understand, but I'll try my best to make it very very easy. But there's a lot of theoretical concept into that, the physics and the psychology and the mathematics and the statistics and all kinds of combined into algorithms. I'll try my best to make it as simple as possible, but it gonna be a little bumpy road. Let me caution you that. So but you will understand, it will be very interesting. So please pay attention. Switch all your cell phone and everything for the next 2 hours. You'll get a break in between, but for next 2 hours, you can look at your messages and everything during the break, but don't miss out everything, because the next two sessions, the master algorithm will talk out everything about computer and AI algorithm. And if you get it right, probably you may not get it right in next two sessions because it's so vast, but you will have a at least 50,000 feet idea about what the whole thing all about. And because we are an ongoing learning process, even after this 15 weeks of learning session is over, we'll still be having some kind of a workshop broadcast on an ongoing basis. So you will learn everything. So eventually you learn everything about algorithm, master algorithm. Some of you, even you will start building your own algorithm. That's our idea. We'll do that in future. That will be on a hands-on stuff. So having said that, so this is the master algorithm. Now let me go here and talk about all those things. Just a minute. I have to just adjust this thing here. And so what is an algorithm? An algorithm consists of a sequence of instruction guiding a computer's action. Computers composed of billions of transistors, execute algorithm by toggling these switches billions of times per second. As I mentioned even earlier, so basically underneath the computer, underneath your keyboards and everything, so there is a processor. What is the processor? Processor is nothing but a set of microchips. And what is a microchip? Inside the microchip, there are lots of transistors packed in a chip, in a very tiny chip. And then those tiny chips are basically okay. Those tiny chips are packed with transistors, and these transistors are basically uh, have two states. You know, switch on and off, 0 and 1. And if you have uh, studied, if you have come from software or electrical electronics engineering background, so you must have studied something called digital electronics. So digital electronics digital electronics basically uh, uh, it's all about and gate, nor gate, and all kinds of stuff. And I'm sure it's any student, I don't know, Utkarsh is there not, I'm sure he has studied it. So anybody who is doing like a third year of electronics or computer science knows what is and gate, nor gate, and those kind of stuff. So I don't want to get into all the details, but think of it, it's a switching state. Okay, it's a 0 and 1, 0 and 1, 0 and 1. Because of the 0 and 1 switching state, or everything converted into number, and those number converted into some kind of a, whenever you have the number, you can use mathematics basically. Okay, so that's about it. So now the simple algorithm can be depicted using symbols representing this operation precision. So what are the operation, like yes or no, 0 or 1, that kind of a thing, and or not, or and or not, that kind of operation. So but what is the difference? It's like suppose you are trying to cook something, cook a meal or something, so you have different recipe, and you put like a you know salt and some spices and everything. And then you hit, suppose you're cooking some kind of a chicken soup or something. And but every time you put the recipe, and every time you do the exactly whatever you're doing, but still you don't get the same taste every time, because it doesn't give you the same output. Okay, so but in the algorithm, it gives you the same output all the time. So whatever the ingredients you put, you'll get the same algorithm all the time. So mastery of a subject is often equated the ability to express it as an algorithm or equation. So equations are like Newton's second law serve as an algorithm guiding the computations and problem solving. So Newton's second law illustrates that essence of an algorithm, breaking down a problem into explicit steps. So these are all algorithm. We have in our own brain. There's an algorithm. So we learn something, some concept, and then we express it in some kind of a uh, you know our own way. Probably in mathematical way, and that becomes an algorithm. Okay, so that's about it. In science, the theories must be expressively as algorithm to be considered rigorous and usable. So algorithms are not just theories but also practical tools, similar to devices engineers, scientists, and engineers. Computer scientists specialize in creating algorithms which serves as both theories, practical tools for problem solving. Designing algorithm is a challenging task. As I said, algorithm must be translated into computer readable languages like Java and Python. So all the algorithm needs to be translated. I'll give you an example. So suppose, and this will you like it, because all our human thought process is a kind of algorithm basically. So how that algorithm we understand, probably we can understand using some kind of a mathematical equation. So we model it. We model our thought process in some kind of a mathematical equation. And once you have those mathematical equation, The computer doesn't understand mathematical equations. So you have to program it using language like a Python or Java. AI language is Python or R, and there are other tools as a C++. So practically Python is much a popular language, and we have already taken a class on Python, and there will be another advanced Python class. So don't worry about it, you will be covered. So algorithm can be combined with other algorithms, and this is the thing. So you have one algorithm and you combine with other algorithm basically and produce a new ones. So that's the best part of it. So basically a master algorithm is when you combine all the algorithm into one algorithm, and which makes all the other algorithm work as per requirement. So similar like a brain, our brain is a master algorithm. Basically there are many different algorithm playing in my our brain, logical reasoning or all kinds of a different intelligence, but our brain functions like one algorithm, and then all those different kind of intelligence like singing, dancing, playing, writing an essay or learning something. These are all different algorithm our brain works, and then you put it in a that, and then it becomes a master algorithm. So how we can simulate the human kind of a brain, you know the function of a human brain into a computer, and that is what this really is all about. Then the question say, hey, human brains are not dangerous. Yes, of course there are a lot of criminals out there. Of course human brains are much dangerous than anything else. Now if the because a lot of algorithm within that brain just 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 go wrong, and that's right, humans become criminals basically because they're taught the way they grow up or whatever that happened, they just don't want to think like a normal ordinary human being. They want to do something stupid or something mischievous, and that's what they become criminal, probably greed or something, I don't know. Every criminal is different, but their algorithm is different now because it doesn't malfunction, but it functions in some different way. They think of it, what Jeffrey Hinton is saying. And if we have the human brain like a massive algorithm, extremely powerful, then all the human intelligence together, and then it just thinks like because of the some defect in algorithm, thinks like a criminal, it will destroy everything. Okay, so that's the main part of what Jeffrey Hinton said. Having said that, so every algorithm has an input and output. Data goes into it, the algorithm processes it, and the result comes out. So basically, you have the input. Think of it some kind of a black box. So think of it. So you have an input, and with that input, you send the data. It does some processing, and then it gives you a output. Think of it that what is happening inside the black box, that's algorithm, and that you really need to understand. The machine learning reverses this process. Input includes data and desired result. Output is the algorithm that transforms one into another. Now what happened is in the algorithm, basically it machine learning is reverses the process. That means input includes data and the desired result, and output algorithm that transfer one into another. So it's not like a, okay, this is a difficult concept to understand. Okay, suppose you have the desired result. Suppose, okay, let's see, like if you show the machine a picture of dog and a cat, and you're telling the machine, okay, identify is it a dog or a cat. We are going to do the lab, we'll do that, we'll run this algorithm in a lab in our deep learning, I think the Polytechnic or something. We have a hands-on, the people who are hands-on stay in our track, and you will be able to do that. So but I'm taking from that simple example. So basically you are not only giving some input with the data, but also you are giving the result, and the algorithm reverses that process and give you the result knowing the result earlier, because we are showing the result like a cat or dog, and now you figure it out. Machine learning, you figure it out which is a cat or dog. So it's already knows the result. That's called supervised learning. You're labeling it, giving a result, and then it's going out. It's giving you some output based on whatever result you give. Probably give two choice, it could be 100 choice, different things. So that's called supervised learning. So you are already give some kind of an input, and then with that input you are giving the desired result. And unsupervised learning is when you don't give the desired result, machine has to guess of his own. Okay, so that's a different thing, we'll cover that. The machine learning ability for self programming is both powerful and potentially daunting. As I said, Dr. Hinton said, I saw this video, because the machine learning algorithm is so powerful and so beautiful at the same time. I would like to use it beautiful instead of powerful, that it creates other algorithms. So it's very powerful. But when you are really, it is creating other algorithm. But what happened? It's creating bad algorithm. Okay, it may happen. That's the reason what that Dr. Jeffrey Hinton said that. So the machine learning can be seen as the inverse of programming, akin to how square roots are the inverse of square, or integration is the inverse of differentiation. So if you say 4 square equal to 16, but if you want to say what is the square root of 16, you inverse it, it becomes 4. It's like a square root. Similarly, so programming, what you really do with programming, you just inverse it. Because programming, it follows some kind of a set of rules and everything. Okay. And then once you have the set of rules and everything, and then it just give you desired output. But if you inverse it, it becomes machine learning. That means it doesn't have the set of rules, it figure it out, and then it also has the desired output. Now it is going to tell you whether the desired output is correct or wrong and that kind of stuff. So basically, it has its own intelligence. Programming is not intelligence. Programming, just it follows some set of rules. But when you put intelligence into the programming, it becomes machine learning. Why you call machine learning? That means the machine. What is machine? Machine could be a computer. Mostly it's computer. It could be a server. It could be some kind of a camera fitted with some kind of processing. It could be your IoT, Internet of Things. It could be all kinds of stuff. So basically, when that machine, where there's some kind of a chip, installed in that machine, mostly server or computer, but not always, and it learns something, it's called machine learning. So we are just telling that machine to learn something based on predefined some kind of a rules. And what are those predefined rules, how you can build the algorithm. We already talk about algorithm, and everything run on the algorithm. So in a way, computer programming is also algorithm. It's not like it's not algorithm. Yes, algorithm, but it follows some defined predefined rules. You just don't go out all the way, and it just doesn't predict something, if it is, because it doesn't learn anything. Whereas the machine learning, it learns from some pattern. Okay, and when that pattern, I mean, I explained earlier also, when it learns the pattern and it predicts something based on the pattern, that means it learns something. We also humans learn something from the pattern. I'll give you an example. Last time also I gave it. A little girl of 4 years old or 5 years old, she sees a dog at home all the time. So she learns what is a dog, because she learns the pattern. A dog is usually a furry dog, sounds like a wow wow or something, like a different sound it has. And then it runs, it plays, it eats, it has 4 legs and all. And it always wags tails because it likes at least the humans at home. And sometimes it yells, really bark at a stranger. A 4-year-old kid or 3-year-old kid learns that, because she learns the pattern. Now, when she sees the cat first time, she doesn't know, but she knows that's not dog. Because why that's a dog? Because she knows the pattern. What are the pattern? What are the characteristics of a dog? On the cat, she doesn't find that. So she doesn't find that same pattern in a cat. Now she sees a cat 2 3 times and she understands the cat. Cats are different looking. Cats have a different sound. Cats are usually quiet, not as playful as dog, and those kind of stuff. And then cat sits everywhere, somewhere very quiet. some kind of a quiet element, but at the same time, different. And sometimes they don't get along with dog, and they make a different kind of a sound. When she sees two, three those kind of a cat, because of the human brain, that's the way it is. And she learns the cat has different pattern. And now she goes to a place where she sees a very, very different kind of a cat, which she has never seen in her life. Some kind of a Siberian cat or something. And she knows it's a cat because she understood from the pattern. Or she sees a dog, some kind of a weird, breed, some kind of a very, very different. Nobody has seen it, like a Siberian dog, a Siberian husky or something. She sees it, but she knows from the pattern that that's a dog, and she says that always. And if she makes a mistake, and I'll come to that's called overfitting. I'll let you know in that next hour, end of the lecture, what is overfitting, what is underfitting. Just keep that thought in mind. Now we go to the next, and we move from there. So some learner acquire knowledge such as the fact that humans are mortal, while others learn skills like riding and bicycle. So there are two types of learning. Basically, you acquire knowledge as a humans are mortal. If you are human, you are gonna die. That's a knowledge. That's not a skills. Okay, you learn it. You learn it through wisdom or whatever. But when you try to learn a bicycle or or some kind of even computer skills or something, that's not knowledge. It's a skills. You're acquiring skills, so you understand. But both are in both process, some kind of a learning involved. So skills are typically expressed as procedure, providing step-by-step instruction. As I said, bicycle or typing or everything, there's a step-by-step instruction. The complexity lies is the knowledge underlying this procedure. For example, identifying a spam emails requires understanding a pattern. Now, so basically, now you understand the concept. The basically skills, there's no pattern involved in it. It's just a step-by-step instruction. Like first time you're driving a car, you know that there's a road ahead, and then you have the steering wheel, and you turn left and right, and there's a brake there, and you slow down, you use the throttle or accelerator, or that kind of a stuff. And these are all step by step instructions. These are all skills. You're not learning any pattern out of that. But suppose you were really trying to learn some kind of pattern, like a how dog, how what is a dog and what is a cat. You just learn the pattern of behavioral and certain patterns of how they look and how they sound, that kind of thing. So you're learning a pattern, you're not learning a skill that time. So you understand the difference. In a subfield of artificial intelligence has become expansive and successful that is surpassed traditional. So machine learning, so when you recognize this pattern with statistical modeling, and we're going to do some hands-on stuff also, how to recognize pattern, how to recognize, how to distinguish dog and a cat, using programming and different mathematical equation, some kind of a deep stuff. But that will do at the end of this, so stay with us, it will be very easy for you. The primary goal of the AI used to be a teaching computers to perform tasks better than humans, with learning being a critical aspect. Machine learning impact the business of evidence. For example, Google like employs learning algorithm to predict click likelihood. So this is now you are learning. When the machine learns some patterns, why Google is so such a valuable company? It used to be still now today, but why there were when if you are old enough who saw the internet, in like early 90s, there is to be search engine like a Yahoo, Alta Vista. I don't know if you heard of Alta Vista, Yahoo, and then Bing came later, and there were many search engine, and Google came little late. So when Google came little late, what happened is, but Google came with a better algorithm, better intelligence, because Google search engine learns a very learns the pattern, because internet is so vast, and there's something called indexing and clicking and everything. So it really, Google is what? It just, you search something keyword, it gives you all the information, at the same time related to that keyword, it shows you some advertisement. Okay. And if you people, they just, incite you to click on the advertisement. So when you click on the advertisement, more Google gets a click, more Google makes money. I've never seen such a easy way to make money in the world. People click, Google gets some money. Okay, but underneath that, huge amount of intelligence is there, huge amount of computing power is there. That's what it is, Google. But ultimately, what the product? Clicking, click product. So if the more people click on the ad, more advertisement dollar Google gets. At the same time, more benefit for the advertiser. Like, suppose I'm a web design company and I'm putting ad on the Google that I do the best. I'm the best, web designer in California, and I want more and more people click, and so that more and more people visit my website, and it's a number game basically. A certain person of it will really convert into customer. That's what I want. So more click is beneficial for me as an advertiser to really get more customer, and more clicks beneficial to Google as a provider, because more clicks means more money for Google. It's a win-win situation. Okay, that algorithm really does well, better than Yahoo, Bing, and others. That's what the Google. So you understand, it's all machine learning stuff, intelligence beneath it. So machine learning accelerates scientific method by quickly generating, testing, and refining hypotheses. So we have many hypotheses. I'll just go over this at first because there's a whole lot of things to cover. And then while scientists may spend a lifetime testing a few hundred hypotheses, machine learning system can perform the same task in seconds. Very self-explanatory. Machine learning automates the process of discovery, revolutionizing both sciences and business. Progress in every field of science requires data that matches the complexity of the studied phenomena. So now this is what it is, and this is really, I mean, this is my lifelong question, why physics, and this I understood why physics become the first science, if you look at the history of science, what came, first in the world is mathematics. And then after that, immediately, but not, it took like a several thousand years, the first really main branch of science, it came, is the physics is the first science. It really came into the world. It was there, but people really started learning physics or understanding physics. Why? Because lots of data were available. How? Because physics means it's a physical world. The gravity, the Newton saw that apple was dropping instead of flying. So that's a data basically. Evidence that why the apple dropped on the ground instead of flying. So he understood that then gravitation came and all kinds of astronomy data and everything. Through your observation, you're collecting lots of data. But where is in biological science, those data was not available because there's no such thing called Microsoft those days, like several hundred years ago. And then if you really want to understand, even to dissect a frog, you can dissect a frog, you can see a lot of stuff, but you cannot see everything under the microscope because there wasn't any microscope. Okay, people never thought. So those data are not available. Similarly with chemistry, there are lots of chemical process were there, but to get into some kind of a chemical lab, test tube, this, that, although there is something called alchemy, but alchemy is really, like a came way after, many hundred years after the physics came. Okay, so that's the reason, because of all those things happening. And there's something called Skycat project utilizes learning algorithm now. And this is what the machine learning is the good about. So now what happened is, usually and traditionally astronomer, they just go and with a very powerful telescope, they observe all the planetary position and all. And they have lot of observatory. We have one at the top of Foothill College. I don't know people who are from Bay Area visited that place or not. I visited, and there are some. total lunar eclipse or something there, and they were showing it through their telescope. It was overcrowded. So people in the Bay Area know Foothill College. On top of that, there's an observatory. So those kind of observatories all over the world, and they have the powerful telescope. And there's one, what is called, very powerful. I forgot the name. Okay, but anyway, you got the idea. But now what they are doing is the machine learning. They take the picture of all the skies, and then with the through the machine learning, they try to understand the different astronomical pattern and all those things much accurately than he actually physically observing all the sky through very powerful telescope. So that's the advance, because algorithm is trying to understand. Similarly, x-ray, so I mean, I talked to a radiologist here, and he's very interested in, but he's so super busy. Probably in future he wants to develop some kind of AI learning tool for that, but it's already there. So what happened is, uh, if somebody is lance x-ray, and basically the radiologist basically wants to figure it out whether one particular spot it found, whether it's a cancer or something, or lung cancer or not. And if we can detect it earlier, then it can be cured. So that's what the radiologists do. The better the radiologist detect that, the better the radiologist, as far as his reputation is concerned. So the best of the best radiologists, based on their experience, they see the x-ray, and then they say, oh, that's a spot, it's definitely a cancer. And then they can save a lot of cancer patients. But they see through their human eyes, and there's something called, what's that I develop a product using that for this Bay Area radiology. What's the name called? What image? There's some term, I forgot it. But they have that and some kind of x-ray, and they have the light beneath that. They put it on a box. You have seen that, and they detect it. Okay, and then that's it. But that kind of a detection through eyes and based on experience is not accurate. Now machine learning can really go even tiny dot that even ordinary human eye, even the best power, but the perfect 2020 vision human eye cannot detect. It can detect, and it can really detect in such a powerful way. Even there's a tiny little dot that radiologist could never find, it can find and tell you whether it's a cancer or not. So that kind of stuff. Okay. So mm, so machine learning has shown remarkable resilience. You see this, it can begin predicting stock. I'm just going. So there is some .com bust, but why the machine learning really all of a sudden everybody started talking about AI, and the reason is it happened for bad, but I mean, I don't want to take that example. It's a bad example, but it's actually a fact. 9/11, September 11 happened, and all of us old enough to saw that, and I was shocked. I was here, in 2001, and then before I go to, I was trying to leave the office, and then Kathy, one of our office manager, called me and said, Ahmed, turn on the TV. I said, what happened? They turn on the TV. Don't come out of home. Don't. Nobody's coming to work today. I said, what happened? He said, just do this. Oh my God, early in the morning. Oh my God, it happened in New York, and we are all glued to the table, TV. All whole world knew. It was a disaster. But that time, machine learning and also the what you call the deep learning was not advanced. It was an advance. There were camera, but it could never detect. It could never detect those kind of a signal and all. So all of a sudden, everybody said, oh my God, if we had the advanced AI, we could have prevented it. So sometimes disaster is not a good example, but it really, the necessity is the mother of invention. That really happened. Okay. So somebody please, turn up your camera is distracting. I could see like somebody is doing something, it's distracting me. If you don't want to, be, just switch up your camera. I don't want to see, what is going on, please. Okay, it's distracting me actually. It's just, I'm just looking at somebody else trying to do something. Anyway, so, and probably he's not paying attention. These are the things happen. People don't pay attention, they just run it and they do their own stuff. I don't know why they do that. They could just watch a movie instead, that would be better. But anyway, so uh so this kind of things happen, and then all of a sudden everybody says, okay, we had the machine learning, we had the AI, it is in the cold storage. Let's take all the equation out. Let's pump all the money. Government and all the lab and everybody started really doing something very big stuff so that we can invent the AI as soon as possible. We can detect such kind of a thing that should never happen. And then really the invention of the machine learning speed up. She said, 9/11 attacks propeller machine learning to the forefront of war on terror, because we were really war on terror. And then there's a web 2.0, and then the learning algorithm enables this advancement, analyzing data and extracting pattern. So what we are doing is basically, so machine learning nothing but, so what you are learning basically, you're learning everything from pattern. Basically you are extracting pattern. Okay, once you extract pattern, and then you can do a lot of things. So that's about it. So machine learning learns from data, generalizes example, ML model generalizes patterns, learn from training data and make prediction. Absolutely. Adapts new data, task specific, flexible algorithm can be applied to wide range of tasks across different domain, requires level data, as I said, supervised learning. Unsupervised learning. Supervised learning is when you show the machine 10,000 picture of dog, and he said, this is the picture of dog, this is the picture of dog. So if machine sees the 10,000 picture of dog, and machine sees the 10,000 picture of cat, then when it sees it, it learns it. It's called training data. There's a different way to do that. I'm not getting into technical details. When it learns it, and then if you see a cat, it recognizes it cat because it already learned the pattern of a picture from different angle. Okay, and this is called supervised learning. That means you are giving it some kind of a label data to learn from it. And when you don't give it a label data, it's unsupervised learning. That's more complex. We'll talk about it in the future. Let's stay with this. Then tuning high parameters, ML model involves tuning hyperparameters to optimize performance. We'll get into that. And the programming is basically, we say, rule based, deterministic, task specific, limited flexibility, direct control, well defined logic, no learning from data. It doesn't learn. So we already discussed that. So, in summary, the key difference between machine learning and programming lies in their problem solving approaches. Machine learning learns patterns and relationship. We already talk about that from data, while programming involves writing explicit instruction or rules. As I said, knowledge, which is skills and knowledge. You understand, if you're trying to, learn how to drive a car, these are all skill-based detailed set of instruction, no knowledge. Okay, but ML learn can perform wide range of tasks, and there's a wide range of applications and blah blah blah. I'm not going to talk more on that. So the question rises, how minimal can the assumption be? So there are a lot of assumptions also it makes in terms of just a minute, so the question is, single algorithm learn everything from data akin to the human brain or scientific knowledge? A few algorithms responsible for majority of the machine learning applications. So if you see all those applications, there are actually basically not whole lot of algorithm, few algorithm, but they just create, they talk with each other, they have all kinds of complex, setup, and they basically, they run all the whole thing basically. So it's a bunch of algorithm working in tandem basically. Major machine learning algorithm are nearest neighbor, decision tree. We are going to talk about decision tree, Bayesian method, and a certain kind of others, and then we'll talk about deep learning, probably not today, in the next this thing. We'll talk about decision tree, and I'll show you some important aspect of decision tree. Okay, so basically the question arises, how minimal can the assumption and still derive all relevant knowledge from finite data. Now whatever happen is, any assumption you make, basically you got the data, right? But data are not infinite, finite, right? So if you anything for a stock market prediction, so there are lots of data, but those data are finite. Like you analyze the data of last 1 year stock market data, that's finite. But are there any infinite amount of data? No, the stock market itself came like a 200 years ago, sometimes. New York Stock Exchange, whatever the history is. So even those are not recorded, but even if you find all those historical data since the first day of New York Stock Exchange, probably 150 years old data, but you do not have like a 2000 years data. So the finite data, how we can predict something from finite data, what a the assumption is made. It could also learn diverse complex tasks like a DNA structure, and also learning many difficult tasks. Evidence suggests existence of sub-master algorithm. So basically, it there is a then you say, okay, then all these things happen. To what is the relation between this and master algorithm? Basically, the master algorithm, basically, that if there's one algorithm that understand or that does everything, is this possible? Because master algorithm is, we are going towards that, we are not yet. So while analyzing the master algorithm concept, or while explaining the master algorithm concept, we have to understand what the all different algorithm is there, what are the different types of algorithm. We are going to talk about it, how human thinks about it. And human brain, as I said, the first master algorithm, because this is complete. It work in tandem with everything, but it thinks, and it has its own algorithm. So so basically, and it's one algorithm. No, there are, of course, there are different logical process. Every psychologist say every mind is different, everybody think different way based on so many input data we get it. But it thinks that way, it thinks, like that. We can, with one brain, we can learn how to play tennis. With the same brain, we can learn how to play guitar. With the same brain, we can learn how to really learn machine learning. It's the same brain, but it's functioning in different way. Do you have like a three different brain to learn tennis, to learn basically how to play guitar, and then to learn programming? No, it's the same one brain. So inside one brain there could be a one master algorithm. That's what we are talking about. Now how can we have the same master algorithm here in a computer that learns everything? You don't have a separate algorithm, deep learning, decision tree, this, that. Nowadays, everything is like a, there are separate, different algorithms. They just connected with each other. It's different. It becomes very meaningful and powerful. But that's about it. But we are going towards master algorithm. If you want to understand the master algorithm, you have to understand all the different algorithms first. So that's, and then you have to understand how human brains work. Once you understand how human brains work, and then from there, can you build a human brain kind of a functionality for a machine, or that kind of algorithm? That is the question. Answer is yes, but not yet. Okay, so if you understand the entire thing about the master algorithm, pretty much you'll understand all the algorithms in the world. That's the reason I started with master algorithm. Make sense? So, having said that, if you want to take a break, let me continue for another 5 minutes, then we'll take a break because we started 10 minutes late. So, there is a professor, researcher, MIT led Dr. Taco Hens conducted experiments to explore brain. This is a fascinating. This really blew me when I first, this really blew my mind. What? I mean, I'm not a biology guy or something, but this is the Dr. Taco K. Hens, very difficult to pronounce his name, but he's a genius scientist. He experimented something mind blowing. I'll show you what it is. Hold on. I think, yeah, yes. Okay. Wait, I don't know. Probably I accidentally close it. Just a second. Is there any research paper? Give me a second, okay? Mm, no, but anyway, probably I accidentally closed it. There's a site for all those things, okay? Uh, anyway, don't worry about that. It's not that important. Okay. So to show you something, but you understand. So what he did here, probably I'll put it on the Discord. So what he did is, yeah, he used some kind of ferrets were used as a model due to their heightened neural plasticity. So they connected it, and they connected it with their experiment provide insight into brain plasticity mechanism. So how brain is plasticity. So now he's thinking, and this is the proof that brain has only one algorithm, because when you see, okay, we have an algorithm to see and detect things. Okay, when you hear, we have another algorithm to hear and detect things. So suppose if you see a cat or dog, your algorithm, your brain, your through your eyes, it tells you which is a cat or dog. But suppose if you hear, you don't see the cat or dog, but if you hear wow or meow, you know that it's a cat sound and a dog sound. Okay. But similar thing, if you want to do it with machine learning, you have to use two different algorithms. Okay. So, but your brain is one algorithm, immediately finds that pattern. Now, what he did is he switched that, whatever, because he just some kind of a ferret he used and everything. And then what he did is, what people as in his experiment, what people could see with eyes and all the neural connection are all, he switched to some kind of a auditory, neurons and everything. Then he could see that the people or the animal through with them, he did his experiment, really could see through their tongue, not eyes. That's a fascinating. The brains, so he said, for instance, cognitionally blind individual can learn to see their tongue via the sensory substitution devices. So this is the experiment it did. The experiment provided insight into brain plasticity mechanism and potential application in sensory substitution. So what he said is that there is one algorithm basically that is doing that thing basically. So that algorithm somewhere inside our brain, it just switches its function. So of course we see through eyes because there is some kind of our eyeball, and there's some kind of a it functions some kind of a lens, and then it goes and it sends signal through that eyeball. It capture whatever the visual thing we see, it capture like a camera. Then all those it sends the signals to the basically the brain, and the brain says, oh, it's a cat or it's a dog. But that kind of a condition, if you alter and change it and change that same brain connection through eyes to your brain, if you change it and changes to auditory, or that through the tongue because of the sound or something, people really can understand this. They may not, I don't know, I mean, how they will see it, but logically or programmatically it understand that. So that's kind of fascinating. So why I said this Dr. Taco's experiment, because this is a fascinating experiment, and this gives you a basically some kind of a clue what is master algorithm. So if you have that, so brain basically has one algorithm. Okay, that's a master algorithm. And then it does what is that through different sensory and different kind of auditory and all your eyes and everything is connected. But because of this different signal and input it gets, the master algorithm figures out when it sees something, the master algorithm figures out when it hears something, tastes something, like that. So that kind of that's the reason I just wanted to say this, because master algorithm leads to that kind of a thinking, that kind of a human thinking. That is what master algorithm was about. Now, imagine you have a magical tree. So now this is the okay. Now, should we take a break, or you want me to continue? Because it's about 1 hour, little over 1 hour. We can take a break, but this time we'll take a little about 7 minutes break, and we can continue. I can continue, but please, if you want to take a break.
Yeah, it will be a good idea. 5, 7 minutes break.
Okay,
Yeah.
so we'll take a 7 minutes break. Okay.
Okay, sounds good.
Okay. Hmm. Okay. All right. So I put the timer on here. So come back after 7 minutes. Okay. Thank you.
Yes, Kapilji, tell us. You want to tell something?
Uh, yes, Sachin. Actually, I have a question for Amit.
Okay.
And my video is blocked. I think I cannot turn on my video.
Oh, no worries. He's coming.
So regarding the generative AI and AWS, is the same session or?
No, it's a different sessions, right? I think there's a schedule. So we have published a schedule. We can see it over. Yeah.
Yeah. Okay. Are you sending other mail, right? That is another Zoom
Yeah,
ID.
I guess so.
Oh, thank you. I was missed that one. Thank you very much.
Hmm.
What happened?
Yeah, Dada Kapil has a question.
Okay, what is the question?
So like regarding this master algorithm, right? So you are using the word universal, right? So universal means like it is in terms of the steps or the process, right? That is universal. But the actual implementation is going to be different, right? So master algorithm for stock market would be different for the in comparison to master algorithm to the cyber attack, for example.
No. The reason is that master algorithm, just like a brain, I just already said that. It's one algorithm, but its application will be in different. So the master algorithm for stock market uh, and even actually in my basically in my presentation, I'll show you the same algorithm is applied in a different context for different result. This is very much even before the master algorithm. It's all started. To detect spam filter. The same algorithm can be applied to even for stock prediction. So that's the beauty of algorithm. So you don't need to go to the master algorithm rather to do that. At present, it is doing it. At present, the same algorithm is using for different contexts. As I said, right? And I gave you the example. I don't know you heard of it or not. That our brain has the same algorithm. Whether you are learning guitar or learning to play tennis or learning computer programming, it's the same algorithm, but you are using it in a different context to learn something different. As I said this, I don't know you heard that or not. So
No,
that's a,
I heard
okay.
that.
So let's finish. Will please put all your question there. But if you keep on asking me, I won't be able to finish it. Okay, because you didn't get the idea. So I have to finish it. So please, if you are with on our Discord server, ask question. I'll answer it. But you don't need to ask question because if you stay till the end of this, basically end of this presentation, probably you'll be able to understand what I meant. Okay. So everybody can see the screen. I guess I'm sharing it. Everybody could see it. If it is not, let me know. Otherwise, I'm continuing. If it is okay, then just I'll continue. Okay. So imagine you have a magical tree starting from the single seed and growing branches, sprout similar branches, repeating the pattern infinitely. The same similar pattern where parts resemble the whole tree mirrors Mandelbrot's set of intricate repetition of different scales. This is called fractal. I'll show you. Fractal is a fascinating thing. Okay. So basically, when you magnify in a fractal a tree branches or ocean shore something, you will see that the same structure as you multiply, it's same structure actually. Every tiny part of the structure is really the representation of the whole structure. And that John Mandelbrot in 1975 came out with that equation. Okay, this is in physics the equation. Okay, now let me show you the fascination of this fascinating structure called fractal, and then you will understand. So the algorithm also behaves like way. Basic law. This is a fractal. You can see this. This is Wikipedia. In mathematics, fractal is a geometric shape, content, detail, structure, arbitrarily small scale, usually having the fractal dimension strictly exceeding the topological dimension. All Wikipedia definition. But this is fractal. And this is so intricate. Okay, and I was so fascinated about this. Actually, I'm writing a book on fractals. Probably I don't know when, with all the nice picture and all. And 2 years ago, and if you are from India, you will be so proud of this. John Mandelbrot invented this fractal in 1975 with some fractal geometry. But basically, this is fractal. This is Rangoli. We grew up with it during Diwali. Just think of it, how proud your heritage is. 5,000 years ago, our ancestors defined fractals. And now it's so every tutors, every Indian home during Diwali, you will find this. This is nothing but fractals. This is there's something called fractal learning, and this is, you see this is in the nature. I wrote this on Facebook over when I wrote it like 3 years ago. Again, November 13, 2020. This Diwali, when secularists makes you feel guilty burning fireworks, I asked them what is the scientific explanation of Diwali Rangoli. And then I went, and this is the fractal learning. This is the actual, the deep learning, learning. So I just wanted to mention it, not to impress you, just to see that this is what it is. And I was so impressed with that. Not only that, I'll tell you, even I created, these are my own, I created fractal art. These are my own model, not Dali or anything, by the way. Okay, these are all my own model. Before even Dali came, I created my own fractal art using AI. You see this? And these are the painting. I haven't started marketing it, but look at this beauty. This is my own creation model. And if somebody is interested, they can go and buy. I'm not going to make a sales speech here, but it is there. I see incredible AI art. I created and this is before Dali and all those stable diffusion. These are my own model, created all these fractal arts and everything. So I named it incredible AI art. You can see all kinds of a different art there. Even I created some serum picture and everything. But these are all fractals. I just wanted to show you the fractal is very important aspect of machine learning, and this all comes from the one type of pattern, and that replicates everywhere. So that's the idea of it. And so whatever your question is, this question answer here. You get the same pattern and you repeat it and repeat it and repeat it, and then you get it can answer so many things. So that's about fractals coined by this is, let me tell you, in 1975, famous American mathematician Benoit Mandelbrot. I, I have very difficult to pronounce his last name, Mandelbrot. Fractal geometry is fairly new and concept few people understand, seen in nature and nearly everywhere else. Fractals are amazingly unique geometric pattern that repeat at every level of magnification. As you magnify, you see the whole pattern in that little pattern. Absolutely fascinating. Fractals are the backbone behind many scientific concepts. They help us better idea of the how bacteria goes inside, how water freezes, snowflakes, and better comprehension of the brain waves. This is what how the brain wave function. The formula is so integrated that studying them has led to numerous scientific breakthrough. For instance, antennas use fractal to recognize the signal patterns. Factor computer science because of the many facets of nature exhibit fractal properties. The possibilities of their use in science endless. Okay, so this is about fractals. So let's not that. Now you are talking about this is all your questions will be answered, all those things. I don't know what kind of a if you have a computer science background, you will understand the next slide. Otherwise, I'll try to explain basically. Okay. So, and the master algorithm, by the way, somebody asked me this question. Master algorithm is not there yet. We are trying to create it. That's a different thing. Whatever you see, all different algorithm. As you are also right, partially because the stock market algorithm is different, and then other spam filter algorithm is different, because these are different algorithms. There's no such thing for master algorithm yet. That's what we are talking about. So if you missed my first few minutes of lecture, if you joined a little late, then you didn't understand this. I started with Jeffrey Hinton in a video, and he said this would happen. And from there, I started the master algorithm. That master algorithm is going to happen very soon, probably in next 20 years or something. But before that, what are the different steps to get into the master algorithm? But if you understand the master algorithm, you understand all other algorithms. That's the reason I started from the very top to the bottom down, instead of teaching you every little algorithm and trying to connect to, take it to the one universal algorithm. So there is nothing called no such thing called universal algorithm. Master algorithm will be a universal algorithm, but we are not there yet. Okay, so now there is something called polynomial time. Think of the problem had solution that can be found fairly quickly. This is all computer science stuff. So that is called P is a polynomial time, sorting list of numbers or finding a shortest route to a map. That's a polynomial time. This problem belongs to the P class because there are algorithms step by step procedure that can solve them in a reasonable manner. So you're trying to find a sorted route from here to San Francisco, or that's kind of, or sorting a list of numbers. Suppose you have like a 10,000 numbers and all opposite way, and then you are just trying to sort it. Then the non-deterministic polynomial time. There's a polynomial time, there's a non-deterministic. Pay attention. I would like to pay attention a little bit here on this and then move on fast. Now imagine problems where if someone gives you a solution, you can check it's correct pretty quickly, but finding that solution yourself might take a long time. For example, if you are given a route to visit every city exactly once, you can quickly check if it is the shortest route, but figuring out the shortest route yourself might be tough. This problem are called non-deterministic polynomial time. So if I say that, hey, from here to San Francisco, say, okay, this is okay. Hey, take the 87, this, that. Okay. But it said from here to San Francisco, from here to Fresno, from here to LA, from here to Modesto, from here to Fremont, and I'm giving you like a 10 different cities, even from my home or wherever you are. And then you are trying to figure out the shortest route. So that guy will take a lot of time, because you have to figure out all the different route, figure it out. Okay, this is the shortest way to go to Fremont, this is the shortest way to go to LA, this is the shortest way to go to Modesto or Fresno, like that. So non-deterministic polynomial time. So you understand the polynomial time, shortest route, but when you get a lot of this thing, so P versus NP problem. The biggest question is now, this is really, you'll make you understand this. You pay attention to here. Now what happened is, because this is all the foundation of logic, basically, some kind of algorithm. So now what happened, the biggest question is whether the problems that are easy to check, like a NP problem, which is the polynomial time, are also easy to solve like pre-problem. If they are, it would be amazing, because we could solve a lot of tough problems quickly, like cracking code or optimizing things. But one has been able to prove the same or not, which makes it one of the biggest mysteries of computer science. So if all the problems, like how to figure out from here to go to San Francisco, as I said, this is easy. But if you want to that kind of a easy problem, when you have 100 cities to figure out, and if you do that easy, then it would be easy. But that's the problem here. In simple terms, pre problems are easy to solve, NP problems are easy to check if the solution is right, and we are still trying to figure out if they are the same thing or not. So pre-problem is easy to solve, because it's just trying to figure out one shortest route. But NP problem, that is easy to check, those problems. Suppose somebody is giving you all the routes, and he just said, oh, these are the shortest route or not. And then, he said, okay, then those are very easy. That means there is a in computation term, or, computer science. Then you have to figure out whether P equal to NP or not. This is another important. So that is basically P equal to NP. So just Google it. What is P? What is NP? What is P equal to NP? Kind of a concept. I can go on and explain it, but you got the idea. So now Turing machine. Alan Turing is the guy who really invented a lot of stuff in computer science, and that's why the highest prize, is called Nobel Prize of computer science is in his name. It's called Turing machine. The theoretical model computation proposed by Alan Turing in 1930s. I don't know if there was computer or not, but at least he created some kind of a theoretical model. Consists of tape divided into cells, read, write, head, and can move left or right along the tape. And control unit. The control unit flows a set of rules or instruction algorithm to determine its action based on current state and symbol it reads from the tape. Can simulate any algorithm process and compute any computation function. This was a simple. That means, there's some kind of a read write kind of a tape. I don't know what is that Alan Turing machine really does. Probably I'll have to look at it. There could be some Wikipedia or something. So I would also encourage to read that. But what the idea we get it, that logical deduction involves deriving conclusion from given premises using logical rules and principles. Turing machine can simulate any algorithm process, including those involving logical deductions. Since logical deduction involves following a set of rules to each conclusion, it can be represented as an algorithm. I'll explain it to you. Turing machine can execute this algorithm by following a set of instructions to manipulate symbols on tape, thus simulating the process of logical deduction. So basically, is basically what he's saying is, so there is very primitive kind of a thing, very rudimentary thing, but the logic is not that. Logic is very sophisticated. He said that the control units rules of a to determine the action based on current state and symbol it reads from the tape. So basically, it just give you two right or wrong, right or wrong answer. The tape says right, this is right, this is wrong, this is right, this is wrong. And from that right and wrong, you can really control that unit. Basically, any logical unit is right? It is right or wrong. The picture is a cat, picture of cat or dog. Picture of cat, right or wrong. Picture of dog, right or wrong. That's the logical conclusion. Okay. And with that, any kind of algorithm we can really, have, that kind of a process, and that is called the what is called the instruction symbol and process called logical deduction. So you are basically logically deduce some kind of answer to it. You are logically doing it, yes or no kind of answer, basically right or wrong kind of answer. So this is a very primitive, some kind of early logic in computer science. That's what Alan Turing is very famous, and he did so many other stuff also in 1930s. I don't know what was available that time. So what is the Turing test then? Thesis states that a problem solvable by logical deduction can be represented as an algorithm and executed by Turing machine, capturing the concept of effective computation. So anything that can be solved by a logical deduction of algorithm by Turing machine, then it's some kind of an effective computation. Similarly, the master algorithm is to induction, process of learning. What is Turing machine is the deduction. It can learn to simulate any other algorithm by observing example of input-output behavior. So what the Turing machine does is basically it observes the output of input-output behavior, isn't it? You tape and read and write and wrong, very similar thing, very similar way. But do you think that turning machine basically observe that kind of stuff? Just as there are various models of computation equivalent to turning machine, there may be multiple formulation of universal learner. Here you go. You ask me, what is universal learner? This is what it is. What is universal algorithm? Now it makes sense. However, the goal is to find the first such formulation akin to turning discovery of general purpose of computing. So, if you go by the logic, there may be a multiple formulation of a universal learner. So there could be several universal learner. That is what it's saying. That is what you're trying to say. But that is what it is. The turning machine can really, because if you really do the logical deduction based on the turning machine, then there could be multiple. That's what it is saying. That is what you are asking for. Now, learning algorithm can accurately predict rare, unprecedented event, highlighting their adaptability and capable in machine learning. Okay, in machine learning, complexity lies in data, and the master algorithm task is to assimilate it. Therefore, its simplicity should not be surprising. So basically, what happened is, with all this blah blah blah, let me put it in a very very simple way. So you have the induction machine. So what is that induction machine does? It's just a turning machine, but is that the master algorithm is to induction, the process of learning, what the turning machine is to deduction. So the master algorithm is the process of learning. Makes sense now. So if you master algorithm is not a one algorithm, basically, okay, if how do I describe? So if you have done any kind of a deep learning has a lot of branches, reinforcement learning, and then the convolutional neural network, all kinds of learning, deep learning stuff. I'm getting into detail. People who are not familiar with this, it will be very difficult to understand, but let me make it say, these are a different logical method to do something. Okay, in terms of see something, hear something, understand. So basically what he's doing is going to understand some pattern, and based on that understanding of the pattern, it predicts something or it recognizes something. It gives you some kind of a output, right or wrong, similar to turning machine. So basically, as I said, turning machine is give you some kind of a logical deduction, represented an algorithm capturing the concept. So the master algorithm is like basically it's just how you really learning the algorithm can accommodate in machine learning. So basically the everything, all the complexity is in the data, because in the data, whatever the data could be 1 million pictures of dog, 1 million picture of cat. That could be a data. Data could be all kinds of information from stock market. Data could be economic indicators of, say, sub-Saharan Africa, all the human index, all kinds of stuff. And then the master algorithm task is to assimilate it. So what is the machine learning? Lies in so whatever that you're learning, basically the master algorithm is how it is learning. That is what the master algorithm needs to learn how it is learning everything from the data, how the algorithm learning from the data. So basically what happened is, pay attention. So if you have an algorithm that basically understand how all the algorithms are learning, and then it knows that this algorithm A, algorithm B, algorithm C, algorithm D, algorithm A, all different functions are made learning from the data, and the master algorithm learns all the learning pattern of the learning. That becomes master algorithm. Make sense? Okay, so that's what we are talking about now. 5 types of learning. This is, pay attention here, because I want to really different, and then all your learning, all those things really happens from here. So this is very important. So 5 tribes. There are 5 tribes of learning, and if you make a little bit of Google search, you'll find it. There's some Wikipedia article also. So there are different. Because in order to understand the master algorithm, you have to understand the different types of learning. Okay, so different branch of learning basically. So symbolists believe that all intelligence can be broken down into manipulating symbols, much like any mathematician solves equation by replacing expression with others. So you have like a mathematician doing some kind of a differential calculus, and it has symbols. It's turning into symbol that think of a chatbot like Siri or Alexa. This system understands and responds your question by manipulating symbols, word, to generate meaningful purpose. That's a symbolist. Okay, that's a one kind of a machine learning process. Then connectionist. These are the different school of thoughts basically. Connectionist believe in reverse engineering the brain's learning process. This is what the area of Dr. Jeffrey Hinton, whom we just watched in the first 5 minutes. They focus on adjusting the strength of connection between artificial neurons to mimic how the brain learns. There is a deep learning class, very hands-on deep learning class. I think on the 14th week. Please attend, even if you are non-technical. Please attend because it will give you all the answer. How to really mimic the brain process basically in terms of an algorithm, how you do that, how you use mathematical model, how you use Python programming. And I'll show you, there will be a beautiful demonstration. The program will be shown some kind of 10,000 picture of dogs and cat, and then we'll show one picture of dog, one picture of cat, and see whether the program recognizes it or not. That's deep learning. We'll be doing that. I think 14th week, there's a class for that. And so evolutionaries believe in simulating natural selection to drive learning. Like a Charles Darwin, that evolution theory, similar kind of a thing. So it can also create complex learning algorithm. What is the example? Let's see. Genetic algorithm used in optimization problem. This algorithm mimic natural selection by evolving solution over multiple generations to find optimal solutions, such as designing efficient transportation route or scheduled tasks. So this is like a basically you just learn through some kind of evolution process, some kind of optimal solution. Okay, so if you want to schedule some task, or it's like from here to Mumbai, the flight route, what is the best flight route given all the weather condition and all the, because you cannot just fly from all the countries over. That could be some kind of a space aerospace violation, and those in some countries really do that, especially your enemy countries. So if you are flying from India, Air India, it cannot flow over the Pakistan, because that's a country you're violating their airspace. So that kind of a thing, then you figure it out what the minimum optimal way you can really go fast again, diverting all kinds of a weather problem on the way. So when you do n number of times, and it's evolved into some kind of optimal solution. That's called evolutionaries. Okay, not that very good nowadays, but it has some kind of application that's still going on. It started that way, like that, so there's no complaint about it. Okay, we are just talking about different school of thought. That doesn't mean all the school of thoughts are based on all, and none of them are not used. So that's a then Bayesian. So if you know the statistics, what is the Bayesian focus on uncertainty in learning. They see all knowledge are uncertain, view learning itself from uncertain. Example, spam filters. We are going to talk about spam filters in email. This filter use Bayesian inference to assess the likelihood that an email is spam based on various features like keyword, sender. We have a case study on that, but we'll talk more about that. So that's a Bayesian statistics. If you are good at statistics, if you come from that maths and statistics background, you know what it is. And then there's something called analogizer. Analogizer emphasizes recognizing similarity between situation to make inferences. They infer similarities based on how similar two situations are. Example, recommendation system like used by Netflix or Spotify. This system recommend movies or songs based on similarities with other users who have similar viewing or listening habit. So basically it's analog, guys, that it's like a similarities. Suppose if you have kids at home, then the kids love all the Disney movies, and you want them to watch all the Disney movies, Lion King and all those things. And then you watch the Lion King, the latest edition, whichever the latest version came, and then immediately the Netflix suggests what the people who watch the Lion King, other kids also watch certain things, because Netflix figured out your kid taste, okay, or what you really as a parent want your kids to learn. So that kind of a thing, analogy, you get the idea. So each tribe offers unique approach to the machine learning, and researchers often combine ideas from multiple tribes to develop more powerful learning algorithms. The key is you develop, these are the 5 different tribes, and I encourage you to Google it, go to their Wikipedia, learn different things, because on our next workshop we're going to use all those things and create something more meaningful, and then we'll that will make sense that time, how these tribes work with each other. Most of the times, you cannot find similarities in all of them, but you can take good things here, good things there, and see how the master algorithm can be built in the future. Okay, now then we are talking about rationalism, Bayesian. Then rationalists believe that knowledge is primarily acquired through reason and logical deduction, and empiricism, which is empiricist, on the other hand, argue that knowledge comes primarily from sensory experience. So this is rationalism theory. I don't want to get into all those things, but when required, I'll come and with this thing. So regarding machine learning, incorporates elements of both rationalism and empiricism. It's both, because you have to be rational and you have to be empiricist also. Rational aspect, machine learning algorithm often rely on logical reasoning and mathematical principle of analyze the data. Empiricist aspect, the same time machine learning heavily relies on empirical data and observation. Okay, like one of these, our Jeffrey Hinton, he is basically empiricist. Okay, so regarding, then there is something called David Hume skepticism. Here is an important question about the limitation of human knowledge and the ability to induction. I'll tell you what it is. Hume's problem. Hume argued that our knowledge of the world is based on experiences, okay, but we cannot be certain that the future will resemble the past. This skepticism challenges the foundation of scientific inquiry and raises question about the reliability of machine learning algorithms, which also rely on the past data to make prediction about the future. I'll tell you this, and uh, suppose and this is, I think, Butner Russell example or something. A turkey, suppose the turkey understand the pattern. He gets a food every day 9 o'clock. He says, oh, 9 o'clock, I get a food. At 9 o'clock, I get food. Guess what? On the Thanksgiving day, his head is, poor guy, animal's head is chopped. All what happened? That's basically Hume's problem. The guys understand the pattern. The poor animal every day for last 6 months has been fed at 9 o'clock. But one morning, 9 o'clock, his head is chopped. It's a Thanksgiving day. Period. Cut off. So what happened? That's a Hume's problem. Basically, what happens is you are based on certain pattern. You're predicting the future, but sometimes the future is basically unpredictable. Totally. So that's a human problem. Hume's problem refers to the philosophical challenge posed by David Hume regarding the problem of induction. This is our problem, which are forms of reasoning where we draw general conclusion based on specific observation or experiences. So what happened is the turkey observation that every day he gets food, it gets food at 9 o'clock, 9 o'clock in the morning on Thanksgiving Day, its poor animal's head is chopped. So what happened to his all the observation for last 6 months? That's Hume problem. Remember this. The problem of induction, this leads to the problem of induction. That's all. Which question how we can justify our reliance on induction. If we can logically prove that future will resemble the past. You understand? Now, implication, huge problem and significant implication for the field of like science, But induction is a crucial problem because all the science we rely on the data. That's why weather prediction is so hard, so hard. You ask any atmosphere science guy, PhD and all, he will tell you that it's very, even with the supercomputer, is very, very difficult to predict the weather more than 3 days because it understand all the patterns, this, that, probably last 1000 years data, everything. But the weather change all of a sudden. Hurricane is coming all of a sudden, the eye of the hurricane changes, everybody got relief. On the same time, weather, oh, don't be hurricane because it's going to divert. All of a sudden, whoa, tsunami happened. Nobody even predicted it. So all those data were there. But this is a huge problem. So the implication of heme problems has implication in the field of life sciences, introduce a crucial forming. You get the idea. Now let's move to this. So this is let's do the some kind of an interesting thing. Let's do this a Boolean field representation of spamming email. So what your email is? Your email is you have to detect with your algorithm whether email is a spam email or not. So what are the two state of the spam email? The email is a spam. You are saying it, quantifying it as a 0, 1, and if it is doesn't if it is not a spam, is 0. That means it's a safe email. Now 4 possible state. Look at this. Both the emails are spam is. One of the email is spam and other is not. Again, NS is. That means one of the first email is spam, second is not. On the other way, the second email is spam, the first is not, and both are not spam. So these are the 4 states. Now, if you want to do it mathematically, see what will happen. Let me see. So Hume's problem then applied context email spam detection. So you get the idea. It's 0 and 1. So now the number of combination is 2 to the power. So there are 4 states. So he said 2 to the power n. So 2 to the power n, basically. So you have the 2 email, E to E and and the 2 state basically spam or not. But how many states you get? 2 to the power 2 equal to 4 state. We already defined it here, 4 state. But think of it, when you have 1000 email, that's n to the power 1000. N to the power 1000, how big would be the number? Think of it if you are from maths background, even if you have the high school background, this thing. So the huge problem challenges so this is a huge problem. Now, that doesn't mean there is no algorithm to detect, basically spam email. There is, and they're quite effective, especially the Google's one. Why? Because there is some way you can really bypass this problem and have some kind of that will come. In summary, Hume's problem challenges our confidence in using past observation to predict future. So whatever the past observation, which applies to the task of email detection. So now, so there is another something called, this is a very no free lunch. I really love this thing. No free lunch theorem in the field of optimization was first predicted by David Woolford Will. So I have this research paper and I will upload it to you. I always some kind of a research paper I always follow. So there's no free lunch. So there's a no free lunch paper, and then it's by IEEE. You can see this. David Albaden research is very close. It's about 5 miles from where I live. Harry Road is on the top of the hill. Albaden research, IBM. So when I see it, I got so happy that this is very close to my house. Anyway, so there's a no free lunch. Let me come to this. I'll talk about. I'll just upload this paper. You can read it. So its essence paper outlines the fundamental principle of no free lunch theorem, which essentially state that when it comes to optimization, there is no universally superior algorithm. Instead, performance of an algorithm depends on specific problem it is applied to. In other words, any gains made by one optimization algorithm on a particular set of problem are basically offset by losses of other problem. So again, somebody asked me, there is 2 set of algorithm. Yes, there are 2 set of algorithm. because two set of problem, and this no free lunch kind of a concept applies there. We are not there at the master algorithm yet, so this is the no free. Imagine you have a bunch of friends who are really good at different games, but not so every, see, if you go to friends, they could be, one guy is good at some kind of indoor games like a ping pong ball, one guy is very good at a baseball game, one guy is very good at mountain biking, some trekking. So everybody plays a different game, but one guy cannot be good at all the game, all the games. That's what his universal learning problem. Somebody suggested that, yes, in a way you raised a valid question, but all those answers now I'm talking about, the master algorithm really needs to figure it out how they can bypass that no free lunch theorem. Okay, so this is a good understand. I'm just going. So just like this is in a computer, the idea of optimization problem where you are trying to find out the best solution among many options. The no free lunch theorem reminds us that there is no universal best solution for all problems, and we may need to try different approaches depending on specific problem we are trying to solve. Somebody asked me the question, this answered that. Okay, then there is a sequential set of rules of emails problem. I'm not going to go with this. These are different rule that header analysis, text formulation rule, subject rule, if this point, if it this point, if you this point. So if you go through all those rules, and if you have like a check, like a 10 different, here I listed like a 10 different check, and if it passes all the check, that means its email is not spam. But if it is fail one of the check, the email is spam. What about the hit and misses? Some of the email, probably the same email, but it end up, that's what it happens. Lots of our emails end up, even the Zoom email, lots of people complain and we didn't find it, but please go and check your spam folder. Probably it ended up in your spam folder. So that's kind of a thing. It's happened basically. So this is basically because of the no free lunch. All the rules may not applied everywhere in like a 1 million emails. Like your Google filters every hour, probably 1 million emails. I don't know how many. And not every, all those things, a freelance problem applies there. You cannot optimize like 100%. So that's kind of a problem. You got the idea. Now, this is a Newton's principle. I'll go about 15 minutes extra because there's a whole lot of cover, and then we'll come back, and that's about it. So it's already time, but we started 10 minutes late. So give me about 10 minutes and I'll finish it. So Newton principle, whatever is the true, everything we have seen is the true of everything. That's the Newton. All these thoughts, I'm not going to talk much about it. In our next class, we'll talk about this. So learning is forgetting the details as much as remembering the important parts. Computers are ultimate idiot servant columns. They can remember, I don't know why you put column. Servant, I don't know, probably there's some kind of a typo I did. They can remember everything with no trouble at all, but that's not what we want to do. So if you want to learn something, you're not going to learn every little details. It's not easy, a thing. It will make your brain really spin. Okay, if you want to learn calculus, you know how this gradient difference and all those things, the rate of change of your slope, you know all the basic concept. But every little detail, if you want to remember, then you won't learn the concept at all, because there will be so many different. You forget all the unnecessary details. You learn the concept, or that is learning all about. But in computer stores everything, is remember everything. So basically it's an idiot. Basically, why you need to remember everything? So you need to develop some kind of algorithm that it doesn't remember all the things. Okay, but in computer everything is stored, so it remembers, right? So that's about it. uh, this is a weather prediction, whether it's a role based on the historical data, and then something called underfitting or overfitting a model. So if your data learns lots, and then it overfitting, and if your data doesn't learn, that's underfitting. So the model, there's a concept called underfitting and overfitting. I'll give you an example. It happened in my own life. I saw a little girl in a neighbor's house. She saw she's like 3 years old. and she saw a black dog, and she said, "Oh, such a cute dog, pink color." I said, "What?" And her mom said, "I don't know why she's saying pink color." And I then understood, now I understood she was overfitting, because she, in her room, she has all the Barbie toy, and all the Barbie toys for girls are pink color. So she's overfitted. So she thinks everything is pink color. So kind of she has some kind of color bias in that. That's overfitting. I understand. But at the same time, if she goes and sees all come different type of color, and she just sees like a two different color, and then she cannot distinguish the black color and the pink color, then it's underfitting because she didn't learn yet. So in the data also it happened the same thing. It's overfitting and underfitting. So how you prevent overfitting? You can the model part from exception. Well, these are all technical stuff. You need to really do not make the machine learning learn too much that it only learn one pattern and forget rest. It shouldn't happen. That's overfitting. And if it is learned little, then it's underfitting. So that's a very complex stuff in the machine learning. I'm not going to go into all the details. Probably in our deep learning class, I'll explain it to you. Then there is this is really good one. Leslie Valiant probability approximate correct. Okay, there's a beautiful paper here. I will discuss with you. I'll upload this paper. Uh, Probability approximate correct. This mathematician, this is actually not Leslie Varian, but somebody wrote another paper based on his paper. The highly mathematical stuff. You don't want to get bored, but for your reference, I'll upload it. So if you have some kind of mathematical background, you will understand it. But this is good. This is good. I really read it. I liked it. Okay, so Leslie Valiant probability approximate correct learning framework is a significant contribution to machine learning theory, aimed at understanding the fundamental principles of learning from the data. So what is that explanation? Now you got overfitting problem, you got the underfitting problem, you have the optimization problem, you got the Hume's problem, you got the freelance problem. These are all heavy stuff, but these are all conceptual stuff. Now, this guy, this scientist, Leslie Valiant, to some extent, explain that. Imagine you are trying to learn something new, like identifying shapes. Valiant PSC learning framework is like a guidebook that helps us understand how to learn from example effectively. Similarly, probably approximately correct Bellion's framework tells us that we aim to find a rule like a circles are round. That's probably correct most time and approximately correct for the rest. So this is the probability probably approximate. You learn certain rule, and based on the rule you kind of some kind of a conclusion, some kind of a logic you derive. Same like a spam filter. You see this, you go through all those 10 checkpoint, and see how many filtered, how many this, and from there you see that what are the correct, really which are the correct detection, which are the incorrect detection. Correct is fine because it really did, but which are the incorrect, probably few are numbered and easy to analyze. In that you see why it did that, why it didn't go through all the things. So there you learn some kind of a pattern, and then you approximate. That's a Leslie Valiant uh, probability axiomatic. The main idea, the key areas of Valiant paper include concept of a learner that can generalize from example. You can from example, the notion of sample complexity. So this is all mathematical stuff. I'm not going here. Another popular method is prefer simpler hypothesis. This is very simple. You divide and conquer algorithm implicitly, prefer simpler rules because it stops. So what you happen is you put a stop, and then when you say that there are two positive examples like spam or not spam, and when you correct everything spam, and then you define some kind of a conquer. So these are the correct and these are not correct. You divide it, and then you some kind of a simpler rules you divide and then stop. If that doesn't follow the rule, you stop it. You put some kind of a break in there, and then you go back and you analyze it. Very simpler. And then in that concept, there's something called blindness, because your data, your algorithm is blind. It cannot read the proper data. It's called bias. And then there is another called, variance. I'll tell you the bias, very big example of bias, real life example. I'll tell you, and this happened in real life. Okay, why the bias is so important in your algorithm. If you see this, there is a, and this guy at Carnegie Mellon University, they analyzed Amazon's craft secret AI recruiting engine that shows bias taken women. So what happened is Amazon learned, it's not like everybody did it, but that it basically kind of created some kind of a bias that women are not good engineers. Okay, women are not good technical. No, lots of there are good women scientists, and they are very very good. Because of that, Amazon was their recruiting agency engine, because it filters automatically all the resume, and then it's checking out all the women candidate. They understood it, they fixed it, but they are so nice company that they came out openly and said this, and because of that, this Carnegie Mellon University wrote a paper about it. Very interesting read. I will paste it on the this thing. You can read it whenever this thing. I'll just paste it here on the chat, so you will understand. So that's some kind of a bias. Oh my God, I cannot do this. So I pasted the link here. I don't know. We got pasted or not, I don't know. Let's not waste time. We're running out of. Okay, so now we are on the, so there's something bias, and then if you talk about the so you saw the real life example, then there's some variance. We talk about hallucination in the chat GPT class, that it hallucinates. That's a variation. It's not bias, but it just give you all kinds of weird result. Continuing a fruit of a white prediction example, it's hallucinate. So you have to really make a simplistic logic to have a trade-off between bias and hallucination. So this is a two opposite end of the spectrum, and you have to really draw somewhere into very little bias, very little variance, so that you can have a workable logic. So that's about it. Is about it. So then there is another called Stephen Stanley Jevons. In the late century, he created some kind of a proposed idea, and that's called algorithm design. And he developed a machine learning algorithm that combined induction and deduction. We talk about induction and deduction, the Turing machine and the Hume problem, and it combines that. And then with that, there's a key innovation done by Steve Muggleton and Ray Bontam. I think there's a research paper on downloaded. Let's see if I can down. All those research papers are available. You can make a Google search. It's not like I found it, you cannot find. So no freelance. So no, it's not there. But you will find it if you make a search on this called archive and all those places. So Google Scholar. So these are the practical application. The integration of induction and deduction in machine learning algorithm has had a profound impact on various fields, including artificial intelligence, data mining, pattern recognition. So this is, this is the kind of a theory is there. Then this is the last one I would like to do, because this is the part of the whole thing is called decision tree. And decision tree, everybody knows that you make a decision mentally. You make a decision whether it's going to be rain or rainy, whether it's humidity, outcast, over temperature, high, normal. Yes, so if you want to play, you have to decide whether it is sunny. Okay, you can go play. If it is a humidity, whether the high humidity, you don't want to play, in high humidity. If it is rain, no, you are not going to play. So in your mind, you make all the decision tree. And so that's about it. Now, I will tell you all this. There is And that's about it. I just wanted to wrap it up, but 2 3 things I would like to highlight here. um, uh, there is something called xg boot, and you can, I think I already downloaded a paper. uh, I think I downloaded a paper. uh, no, there's a paper called okay, there is something called xg boot, and I think I accidentally I deleted that. But if you see this Kaggle, and I tell you this, there is you can, this thing I wanted you to really get excited on this. Kaggle is the data set, and Kaggle is actually now it owns by Google. But Kaggle is a place where you can really learn machine learning, and also you can really form a team, and you can participate. They have all kinds of competition. You see this, all kinds of competition, and you can form a team and you can participate. And there is a winner like a get as high as $1 million prize. More than that, I've seen, and at least 10,000 to $1 million, that kind of a prize you get. But even if you come third or fourth in that kind of a competition, because you are in Kaggle competition, all those large companies watch who are the people who are really getting into competition, what is their ranking. This is a sure short way to get a job at Google. I can give you that. So but it owns by Google, but doesn't mean that only the Google comes here. And they also, all those large companies, they'll start a competition because for their own need. And if you can start learning up, and then you can form a team, or they will help you to form a team. I encourage you who are technical, come here, understand all the Kaggle competition are. There are lots of data set, dummy data set, because you need to data set to run. I always get the data set from Kaggle to run my model, test my model. This is the best place to learn. And you can come here, you can learn. These are all free stuff. There's some tutorial also. You can coordinate with this. I tell you, this is, and then this is a sure short way to get a job at Google. I can give you that. Not everybody. Number one thing is you are so distracted. Only few people who can make it to this level, not because they're the smartest, they are the people who can focus along at any subject. And if you and that is my last lecture I gave you, but I have already, this is the reason we created the Indian Engineers Without Border, and I created something called Focus Brilliant. And I want you to watch all those video. I explain it all the time. And there is, this guy is a very world famous psychologist. His name is Dr. Daniel Goleman. It's a Dr. Daniel Goleman on Focus, the secret to high performance and fulfillment. If you want to do really something, really achieve something in life, your focus should be the number one. Number one. If you want to be an Olympic athlete, there's no way. There's no way other way. Have you seen Michael Phelps, the dude who got a 9 gold medal? Have you seen him doing all the time WhatsApp and this thing? He doesn't do that. Probably he's there. He has a team there. Some he outsources it to do it for him. He doesn't do it. He has to have a focus. Any kind of a discipline requires huge lot of focus. I sometimes I really get surprised. Even people at my age are not fakers. I told them the same thing again and again. Come here. There is all kinds of a learning festival. They are all our schedule is here. They just don't go scroll down and learn. They ask me again and again. And I'm the person who's working like a 13, 14 hours a day with so many things. Teaching is one of them. Preparing the material. If I have to tell the same thing to a person who is coming through whatever the way, email or WhatsApp, and asking the same question, it really upset me. I said, what? If you don't have focus, forget it. Go and watch TV with your kids and do something. This is not for you. Forget it. Nobody's asking, nobody's forcing to do it. But if you are really committed to do it, then commitment. And that's the reason there's a beautiful video. All of you go there and watch. I ask everybody to do it. It's a 15-minute video on here, and you go and say, and it says 100% rule will change the life. Benjamin Hardy, he's a very famous TED Talk guy. He said 100% commitment is easier than 90% commitment. So if you want to do something, if you have 90% commitment, it's hard. But if once you make a decision, I'll be 100% committed to it, it's easy. That's it. Because you don't follow anything. Okay, so that's about it. Having said that, I wrap my lecture today. And thank you very much. I'm going to come in the morning, whoever on the, my morning California time, as I said, instead of 7 o'clock, we'll start at 8 o'clock because time is going to change tonight. And if you have any question, I can answer. Otherwise, we can just end the session.
So Amit, I think only the time change for us, and for India it's same 8:30, right?
Yeah. But for a lot of people are joining from California, local also.
Yeah.
Yeah.
For us is 8 o'clock.
Yeah.
Okay.
Uh,
Sounds good. So you are going to send an email tonight, right?
No, I'm not going to do all the LinkedIn and all. I just already said this, and everybody will get a Zoom link.
Yeah.
And I'm
Yes.
going to because this is only for tomorrow, and then we are going to decide what, because evening time also got changed, because we started at 6, so instead of 6 we'll start at 6:30. So this will decide, by Monday and Tuesday, and everybody will get email
Okay.
because there's another 10 weeks to go. But
Okay.
Tomorrow, please come at 8 o'clock if you're in California. If you're outside California, wherever you are in US, everybody knows that time change. That just log in one hour later. And for people in India, it doesn't. It's the same time you come.
So today I registered first day, sir. How we can get the notification through I register IEW.guru website?
No. Did you register? So you will be getting, first of all, you joined Discord. Ravi, could you please upload the instruction for Discord? Just wait for a second. Our intern will upload this instruction to join the Discord server. Very, very easy. You just join the Discord server where we are making all the announcement. So even if you don't get an email or Zoom link, you go and check the Discord server is there. Okay.
It looks like he sent a couple of times, but that is expired. Can you check, Ravi? Yeah.
No. There is already Ravi uploaded the Discord server. This thing, the
So
instruction.
yeah, so you cannot use the same link again and again. You will get a fresh link for every meeting. So if you are already registered, you must be getting the email for the latest link to join the meeting. Just see your spam if you are not getting the regular email, regular inbox.
And the reason, but there actually, let me explain why it is happening. The reason is we just do not want to use the same link again and again, just in order to have our own kind of a group, and we don't want any spammer here. So in order to discourage that spammer, if they have not registered and they somebody gets the link and share with so many other people, and our server gets choked with so many spams and everything, and probably some people will record it. I don't know what they will do. So that's the reason, if people who are registered or at least they joined our Discord server will get the email again and again. This is for our own protection, our own for everybody's protection, basically. Okay.
Maybe my bad. I registered multiple times. Can you add me my email ID? I will send.
No,
Ravi?
just did you register it?
Yes, I registered, but
Then
unfortunately,
you will get the Zoom link every time. Just check your Zoom link 2-3 hours before the session. Sometimes I send it 6 hours, but on the same day. Sometimes you definitely get the Zoom link at least 3 hours before the session.
okay, sir.
And
Not.
also
So how did you get today's link?
I was attended through Meetup page. I
Okay.
came through Meetup page.
Okay.
That is the reason I was not able to get the.
Yes, somebody, yes, but once master algorithm is invented, we would achieve singularity, yes. And that's the reason you can go and watch our some of these. Even I came up with the concept Silicon Valley RAM, how to put those kind of a characteristic in a master algorithm. So I'm like talking about all those things in a very different way. But that's
Yeah, that's the
so go
important thing.
yeah, so go and watch some of our videos on our YouTube channel, and I'll put it on the Discord. But if you are on the Discord server, every link you will get it. Just join Discord server, everything will get updated. So don't even rely on email sometimes, because you saw that spam filter everything, right? So it's not reliable all the time. But Discord server, you'll get the update link all the time.
Chalo,
Okay.
sir? Yeah, thank you so much, guys. Uh, we are getting a good traction.
Yeah, so a lot of
So,
people came. Thank you. We just
yeah,
got started. A lot of things happening.
yeah,
And so next week, the master algorithm part 2 will be most crucial, because I just wanted to give you some background. What are the difference, Hume's theory, and no free lunch, and all those kind of stuff. So you understand what is the algorithm concept, and then now from the next this thing will be lots of things, how human mind thinks, and then how can simulate that algorithm of human brain into a computer, and then what are the other ways you can do it. Very interesting, very grueling. So please try to join in time, and next week have at least half an hour in, because there's so much things I may not be able to complete in 2 hours. I'll try, but probably I'll have to explain a little bit in certain areas. So have come up with at least 2.5 hour, one half an hour extra. I'm asking you right today, so that you come prepared that this could be. But next week things will be so clear. You'll be thrilled knowing. And by that time, we have training. He's really doing good work. We'll edit all those things. We'll set up all uh, our video. Where you'll get access to the video. We'll set it up on Vimeo. It won't be on a YouTube free kind of stuff. It will be accessible. So you'll get the access code and password and everything. You can watch all our previous sets and again, and then you start thinking of it, and you'll get interested. The idea is to get you on board into the AI journey. Once you are on the board on the AI journey, then things will really start. But I'll have to prepare you for that.
and the other thing is, we are getting new people this time too. So I request to everybody of you, everybody over here, to to spread the message to your friends, right, to other students, because these sessions are invaluable, right? You will not find all these stuff anywhere. So if you like to get your friends or some other fellow students to know about all this stuff, then spread out the message. We need more and more people to take the advantage of these sessions.
Not only that, let me tell you another thing. I think after next week, and then there will be 3 weeks vector database classes. Okay, and there will be a guest speaker from MongoDB. And MongoDB, gave me some mandate to prepare people with vector database. Go and find a Google trend. You will see that vector database is just brand new technology. When I talked about it, I have a separate chapter in my book, which is coming, the revised edition. Everybody will get a free Kindle book. That's my promise to you. And I am going to, in next 6 months, I need 100 people well prepared for vector database. If you are in US, I can get you at least 100K plus job easily. Okay, if you are prepared for vector database kind of a thing with prompt engineering. If you are in India, we are going to set up some kind of a setup. It's very difficult to bring them to basically to United States on H1 visa, because it's too late. If we file your H1 visa, it will be like a first of April. We have another board of directors, Mr. Neeraj Bhatti. I can tell you, it's very difficult. But on the 1st of April, the quota opens, and 2nd of April it oversubscribed 3-4 times. Only way to bring you guys here is on J1 visa. That could be one possibility, or we can set up a parallel nearshore operation in Canada. That is also we are looking at. And the third option is wherever you are in India or in other places, you can really work with us through some kind of a online, work from home kind of a stuff, through some kind of a marketplace. We're going to set up. So it's going to happen in next 6 months or so. So stay with us, everybody. This is the reason we created Indian Engineers Without Border. We are going to create lots of jobs. Everybody benefits. I get good guys as a, as a some kind of a running a company in AI space. I searching, we are all trying to get good people. The Indian Engineers of that border, everybody involved gets learn everything, free learning mostly. Okay, and the companies get really good people. They can hire people. They can get their project done, and all our across the community who are joined, everybody will benefit commercially, academically, and many other ways. And there will be a lot of research collaboration also in the future.
I'm
That's
just
it.
curious, how many people on this call are engineers, or how many people are new?
I don't know. I don't have any idea.
Yeah.
A lot of people, I think most of them. Then every little, I have to ask people, and then that we haven't come to it because we just started and very this thing. Then once we start, even people don't go and register properly, and you are asking for the resume, forget about it. They don't do that. Okay, and even if they give you a resume, I tell you, there's a lady. I can vouch. She's a from a software background. She doesn't even know what is a programming. How can she build with software background? People BS all the time. Okay, I know
But
she's not, but they said that. They said that. What I can do?
but that's okay,
Yeah,
right? You
that's
need not to
okay.
be
That's what I
engineer, right?
said.
You
So
cannot
if
be. You need not to be engineer. Not everybody
somebody,
can be engineer, but as long as you have a reasoning thinking, and the logic, that's fine. So everybody don't want to code, right? They want to understand it.
and
But
that's
we are
the
not going
reason.
to in
Yeah,
that debate.
that's the reason I said engineering. Even again and again, if you have understood, I said
Yeah,
even in my said think like a Wright brothers.
yeah,
Okay, when I said think like a Wright brothers.
yeah.
Okay, I covered that. What is engineering? What is non-engineering? If people who have not attended it, first time attended it, probably they missed it. There could be a video recording. Go and watch it. That's one of the best,
Yeah.
workshop I had so far, isn't it? Such a
Yeah.
so think like so you don't need to
Yeah,
have an engineering
it
degree and
is
all.
first you need to understand it. Coding is the easiest part to do it if you learn it. You need not to be code. There are so many other people, the engineers who can code it. But if you don't understand the concept, even you are an engineer, you cannot do anything, right? So that's the important thing. Okay, guys, let's wrap it for today. It's already
No,
evening
another before
8:34.
everybody goes, somebody says whether we are going to issue certification, yes or no. Yes means people who pass our test will get a certification. Indian Engineers Without Border is a global name. We just cannot, we cannot be like some kind of a, some kind of a tutorial, all those mushroom in everywhere. No, we have to have a brand name, and with that brand name goes with lots of filtration and vetting process. If somebody is willing to take our test with after completion and watching everything again and again, the test will be very rigorous text, and yes, we will issue the certificate. Not only that, we will also personally prepare them to the next level for job offer, and helping them to really prepare for interview. So people who are willing to take the test at the end of this 15-week session, they are welcome, and but without taking any test, there won't be any certification. Okay, so because we have a brand name, okay, and this brand name will grow really big. If you go to any, you just go to project management institute and you said, can you give me a project management certificate? No, sir, you have to have a 3 years experience in project management and take our test, and that takes good luck. People who have taken a PMP test, they know how hard it is. Okay, so it will be like that. So it will be, but you have to go through some vetting process. Having said that, there is another question Dan asked. If you are, how about if you don't want to get into technical track? Yes, this is a non-technical track. We're going to have all kinds of a non-technical track, and there's a huge scope for that, for consulting opportunities, digitization, digital transformation of a company. You'll be talking to CEOs and CTOs and you will be making strategy how to digitize a company, how to go through digital transformation of the company. You won't be doing any kind of a coding, but all kinds of a senior architectural level kind of a work that will be teaching. So that is also, so stay with that. Next few weeks will be very crucial. That's about it.
Yeah, but the only one more minute I can take it, because technical and non-technical session both are critical. If you are a non-technical person, still you need to go to the technical aspect and see the logic of the code. You are not coding, but you should understand the logic, because sometimes when you are discussing with your product managers or the coders or something, your concept, then you should understand how difficult it is to code, right? And what kind of the logic they are doing. Although you are not writing the code, but you should have those. If you have those things, is nothing better than that. So try to attend both the sessions.
I tell you what, working as an accountant in a software company doesn't make you a software engineer. So if you have the software background, say it. If you don't have the software background, say it. No, don't lie, because if you lie, you are not going to learn anything, because you assume that this person has a software background and we go fast. So if you don't have, we have another, we'll have lots of track for people who do not have software background to bring him on board and make him add part with the people with software background. It's gonna be a lengthy process, but you will be part of that process. But if you lie for your own ego, hey, I'm a software person because you worked 10 years ago in a software company as an accountant or something, then you are cheating yourself. Don't cheat yourself. Just be honest.
Okay.
Thank you.
Okay, guys.
All
See you
right.
tomorrow
Thanks.
morning.
So can you please share me the YouTube links, previous recorded one? I missed the old sessions.
Yeah, we'll put it on the Discord. I don't know, but Ravi, you have it handy. Put it on the chat. Otherwise, we'll put it on the Discord.
Yeah.
But all those previous all the session won't be on YouTube. We are not going to make it
We
a
are not going
public
to put on the
YouTube.
YouTube. We are
It
going
will
to
be
put
on
on.
Vimeo, and we'll give you password to access it. We are not there yet, because we have one trainee who is working, a lot of who's doing all the editing, and I'm also busy with so many things. Probably next week we'll be able to start putting up all the videos on Vimeo and give you access. You have to wait a little time. Okay. All right. Okay. All right. Thank you. Thanks everybody.
Bye.
And
Take care.
I'll see you in the morning at 8 o'clock. Whoever in California and whoever in India, your evening time, whatever the time you log in.
8:30.
Yeah. Okay. All right.
Okay,
Thanks.
guys. Bye.
Okay. Bye.